Jai Hind everyone. My dear students, today I am going to present a topic, morphological image processing. This topic is a very important topic in image processing, and I will cover here some preliminaries: erosion, dilation, opening, closing, and hit and miss operations. Myself, Dr. Akhilesh Verma, Assistant Professor in Department of Computer Science and Engineering, will discuss this topic. Let's proceed. Morphology is a branch of biology that deals with the form and the structure of animals and plants. Correct? So, what we are basically targeting, that is the form and the structure of any object. So, morphological image processing certainly will have relation in image processing towards the form and structure. So, if I want a description of a particular region like the shape, we can have a boundaries, or we want to know the skeleton of the shape, we want to know the convex hull of the shape. Okay, so is it possible in image processing, can we have the form and the structure, and the form and structure of a region in an image are very important, because we want some extraction of image component. So, image component means you can say simply the sub region, okay, or simply if a human being is there, we are simply saying that where is face, where is eyes, where are nose, okay. These are the image components or sub regions. So, for that image sub regions, I may look after the shape of the region, like we can have the boundary description, we have the skeleton of particular object, or we need to have a convex hull boundary of a object in an image. So, let's start with some preliminaries that is important and used in the morphological image processing. So, there are two operations. First one is the reflection and the second one is the translation. Okay. There are the mathematical formulation given here, and that can be easily understood with the diagram in the next slide, but first we will focus on the mathematical formulation. So, first operation, reflection, is represented by B cap, okay, and the reflection of set B is denoted by B cap and is defined as all the values W such that when the for a particular value of B for the set capital B, we have a negative, or you can say reflection of small b. So, this is a negative of the coordinates of B. So, if say for example, there is x, y coordinate for B, so certainly minus B will be minus x and minus y, okay. So, this can be easily seen in this example, like this is a set B, okay. So, any point here, example B, will certainly have some value x comma y. So, what will happen if we change the value of x and y to the negative? So, it will move in the another coordinate here, and it will be minus x and minus y. So, this particular point is a reflection of B, okay. So, from this definition we can easily see that B reflection is given by set of those points which are negative of B, and B belongs to the set capital. Likewise, there is another important primary operation that is used in the morphological image processing, that is called as translation of set B. And assuming that there is a point Z okay, in the space Z, and we want to translate this set B with value Z. So, what does it mean? It is represented by a operation B with bracket and subscript small z. It says that it is all the points C such that C is now basically displayed by a coordinate Z. So, it is now B plus Z for all the pixels in B set, capital B set. Okay. Now, this can be explained with this example here. So, we can see here this particular region is now translated to this point. So, whole region is now translated by a value z, z1 comma z2 in this coordinate. So, there is a shifting, it is shifted at this point. So, this is a reflection operation and this is a translation. These two operations are very important and crucial while describing the morphological properties of the image subregions or objects. Now, another important thing that we need to understand in morphological image processing, what is structuring element. So, it is a small set, so means it is a sub part of an image that is basically used to probe an image under the study. So, basically we are searching for object within a image using a small subset of image, and usually it has a certain property that we are trying to find out in the object. So, structuring element are various type. Here are some examples which are given at the top of this figure, and we can see that these structuring element has various shape, and that is basically required to be probed, like this plus sign, this square, this is stride, and this is a diamond look shape that we are interested in finding in the image. So, structuring element is given a boundary rectangular shape by additional padded pixels, so that it can be used in the mathematical formulation. So, the structuring elements converted to rectangular array. So, this array is basically a mathematical representation of structuring element mentioned above in memory, so that computation can be performed. So, these all are marked as 0 and the rest is marked as 1. So, this structuring element is having white background with the black foreground. Likewise, we can have opposite also depending on the requirement of the image. And one important thing is the dot, that is a black point, is the center of the structuring element. Now, example how this structuring element is used, we can see in this particular example there are set A and set B. So, first the set A and set B are given a rectangular matrix or array representation for mathematical computation purpose in the computation. So, we have represented A in the matrix, we have represented B in the matrix. So, if we have a matrix of zeros and ones, we can represent A as well as B for programming purpose. Now, this structuring element B is used to search or probe the shape A, whether this particular shape exists within that, or there is some similarity or probing is required, that is it is available here or not. So, we accommodate the entire structuring element, that B is accommodated when its origin is on the border of original set A. So, we can place at any point here on the border of set A and find out whether it is part of that or not. So, the structuring element as a rectangular array is here is used to process the set A using the structuring element. So, we can see that this set B visits every element in A, and at each location of the origin of B, if B is completely contained in A, that is, it is a part of that A. So, if we say that this particular location is completely part of A, okay, contained as a member of new set, otherwise it is not a member of new set. So, we will include this particular pixel in the member, but if we see other cases like here particularly, we can see that this particular case, this pixel is not part of set. So, this is included and this is not included. Okay. So, finally, we can see the result is looking like this. We found that the set A is reduced to a particular small size, and in this particular boundary, we are able to see the shape. Okay. So, we can see that probe has identified within the region the structuring area. So, this is a probe and we have probed here, it is a part of this subregion. Now, based on the preliminary operation that we have seen, and we have a basic background of some set theory, we define a new operation that is called erosion, and when a set A and B are part of a domain Z square, that is the pixels value, we can define erosion as A is eroded by B and it is denoted by A, big circle with a subtraction sign in between B. So, this symbol is called as erosion symbol. Okay. So, this is a very important symbol that is to be learned, and it is defined that A erosion B is equals to all the set of points Z such that when the structuring element B is translated, B translated by Z is a proper subset of A. Now, this can be also represented by another mathematical formulation, and that is very important, and we can say that otherwise that all those pixels when B is translated, there is an intersection done with A complement. A complement the rest of the image sub object, that is other than A is phi, means there is no intersection between the background and the translation of BZ. So, this is a erosion. This can be explained with this example. So, this is the A and this is the structuring element B, and we can see the dimension A is of size D and D by D, and B is of size D by 4 and D by 4. And when we apply this A erosion B, what will happen? The size of the original A is reduced by this dimension. Why? Because by definition of the erosion, we can easily see what we are saying. When B is translated by Z, it should be a part of A, and otherwise you can say simply when B is translated by Z and intersection of A complement is phi. We can apply both here. Okay. So, what is A complement? A complement is the rest of the thing outside this. Okay. And if we translate B over here image, we can finally say that at all these points the B is a part of set A. Okay. Now, for all the translation operation we perform at the boundary, we can see that only these points are coming to the part of this mathematical expression. Okay, particularly A, B, Z is subset of A. So, finally, we get this particular region as erosion. So, what is the effect of erosion? The size of the object A is reduced or eroded. So, that is why it is called as erosion. Now, if we take another shape, stride, vertical stride. Okay, so you can see what will happen on the A. we can imagine simply that there will be impact more towards the top and the bottom of the object. So, we can see this particular area is eroded and this particular area is eroded. So, what is happening basically, we are putting this B somewhere here on the A and translating such that it is a part of A, and if it is that, then we include that pixel. So, we are including this and this. Finally, we got this as a part of erosion. Now, if we see and apply this on particular image, here you can see there are various size shapes. This is a very big shape, rectangle, a square, and there are some rectangular shapes which are of width, high width, which is medium width, and this is very thin width, and we can see another shape here. So, this particular image is taken to show the size of the A. Okay. Now, if this particular set A is applied with a set of rectangle square structuring element B of size 11 cross 11, 15 cross 15 and 45 cross 45. What is happening? We can see that when we are applying 11 cross 11, okay, so this size is very small. So, what is the impact on that? That any shape which is smaller than 11 cross 11, especially we can see this one has gone, but this size which is larger than 11 cross 11 is remaining here. Okay. So, what it indicates that for with 11 cross 11 structural element, all the sizes which is smaller than 11 cross 11 will be eroded out. Okay. Now, as we change the size of structural element 15 cross 15, what has happened? We can see the one structural element, one shape A which was remaining here is also gone. Fine. And finally, when we applied 45 cross 45 here, we can see that the rest of the A objects which are smaller than 45 cross 45 all has gone. So, what is happening? By erosion, we are basically trying to remove or exclude all the object which is smaller than a structural element. What is the purpose? To identify the bigger size objects or the particular object that we are of interest. So, it is like a reason of interest calculation or many other ways we can use in the image processing. Now, another important operation is a dilation. Dilation is opposite of erosion theoretically, and it has two mathematical formulation, and it is used here as A dilation B. Now, here you can see the circle operation is with plus operation, and we can see that earlier it was circle minus and now it is circle plus. So, minus means we are subtracting, plus means we are adding. So, this is dilation means some addition is there. So, A dilation B means that all set of pixels Z such that when B is reflected and translated and the intersection of this reflected and translated B is computed, there is no phi operation. So, it is like this if it is A, okay, and if this is B. So, we can see at this point there is a intersection and it is not phi. But if we consider A and B is something far away, we can see that A and B has no intersection. So, what they are saying, we are translating B with their mirror reflected set structural element such that it is always intersecting with the A, that is it is not equal to phi. Other form of representing is very interesting, and it says that if you translate the reflected part of B and take an intersection with A, okay, it should be a subpart of A. Okay, so it means that when we displace Z, the translated object structural element B with A always overlap at least one element. This is the theory. Now we can see with an example, same example again, and we can see here that the earlier the shape was this one, now it is added. So this particular area is the gain or plus, or you can say dilation of the object A. So dilated means some expansion is there. Similarly, we have seen that when we are having vertical stride, we have a reduction of size from the top and bottom. Now what will happen when we erode? Certainly it will increase or plus the area on the top and bottom. Okay. Now very interesting example that we can see in the image processing, how erosion and dilation can be used. So we can see here this blur object which is which is showing a very some character which is not visible or not seen by this. So this is large E and A. So what we can perform, we can dilate it, and now the E and A is recognizable. Okay, so it is dilated. Now after erosion and dilation, we have another operation that is called as opening and closing, and these are very interesting operation. Opening generally smooths the contours and an object of object and breaks the narrow isthmus and eliminates the protrusions. Okay. So what does it mean? We can see with the example, but basically when we see the contour of an object, we are basically interested in breaking the small object details, or we want to eliminate the object details, and that is called as isthmus and protrusions. Okay. Closing operation is opposite of that, and basically it is also a smoothing operation, but it is affecting the contour by fusing, means that is they are merging. Okay. So what is happening? It is breaking and it is fusing. So whenever there is a small hole, okay, it will fill it. Okay, some gaps, it will fill that gaps. So opening and closing is likewise opposite operation that we have seen in the erosion and dilation. So with example and mathematical formulation, we can see the opening is defined as A small o b, or small o means opening. Okay. So it is defined as A erosion followed by A erosion B followed by dilation of B. But it seems something like that if we first erode and then dilate, we are doing the reverse operation. So object will remain same. It is not like that. We can see with the example. Similarly, closing is represented as O with dark color, means it is closing operation. So A close B is A dilated by B, then erosion. So we can see the mathematical formulation here. Now opening of set A by structural element B, it can be also represented by mathematical formulation by this, that we are basically taking the union of all the structural element Bz when translated, such that Bz when translated is a subset of A. So what will happen with, we can see with this example, consider this as A, okay, and there is a structural element B. So when we move this B inside this triangle, we will see that at these points the B is basically subset of A, proper subset of B. So we are taking the union of all the Bz. So what is happening? We are taking this first, then adding the another set B, then and so on, and naturally all the points inside that will be always a subset. So finally we will get a boundary which is inside A, and this will be the A opening B. So we will be removing this particular portion, we will be removing this particular portion, this is removing. So opening means we are opening the sharp boundaries. Okay. Now closing with an example. If we roll this B over this shape outside, so we can see here we are rolling inside the shape and we are rolling outside. So when closing, we are rolling outside. So when we are rolling outside, certainly you will see this center point will follow this particular shape. So you can see from here that the this will be the output, and finally you will see that this particular area is now filled. Okay, fine. And there is a the shape changing which is inside of the shape. Okay, and here we can see there is a outside. So what they are saying, outside contour that are eliminated, and here the contours that are small, they are fused or they are filled. Clear? So there is elimination and there is a filling or fusion. Okay. Now, a very interesting operation, the very important part of morphological operation is hit and miss transform. This operation is need to be understood, and what does it means? It means these are the applications of opening and closing, and how opening and closing can be used to improve the fingerprint scan one after another, and finally we get a very good quality fingerprint image without any noise that is available. So this is the application. So hit and miss transform that we are going to learn is very simple. Hit means it is there, miss means it is not there. So there is a set which composed of C, D and E, and we define as C union D union E as A, and if you want to find this W inside set A, so basically what we are saying, whether W is hit here or miss here, so we want to find W in A. So we can see there are various size of shapes available in A, C, D and E. So which particular shape is matching with that particular object in the set A. So if we see, we can find out the A complement, that the rest of A, opposite of A. So this is the opposite of A. Now likewise, if we take a object that is of size D, okay, what is D, which is a shape which is something larger than the shape of W, or you can say a object which is slightly larger than the W, okay, background we can say. So we apply A erosion D, what we will get? We will get a object boundary which is eroding this particular area and also this particular, okay, D we are getting input, and this is finally removed. But what we are saying here, we are doing operation on A complement or A. So depending upon applying W or W minus D. So if you want to apply any operation on A complement, we will use W minus D, and when we want to apply on A, then we will use W. So basically it is a foreground and this is a background. So we want to identify the foreground portion and the background portion of the object. Okay, so that's why we have defined W minus D. So first we have performed the operation A erosion D. So we can see that when this A is eroded by D, it will find the D and it will reduce the content of C. Finally, if we simply take A complement erosion W minus D, that is background, what will happen? It will operate here and it will further find this and it will find this. Okay. So by these two operation, A complement erosion W minus D and this A erosion D, can we have a mathematical formulation like this, intersection of these two operations? So what will happen? Intersection of these operations will result into this particular point. Okay. So finally, what we are getting, a new operation that is called as A asterisk B, and this is called A hit hit and miss transform, and it is a basically a logical operation A erosion D, that is finding A background portion, okay, foreground portion, sorry, and intersection with the background portion W minus D, and that will result into A hit and miss transform. So, Jai Hind everyone, this is a very important topic for understanding the morphological image processing as a basic concept that will create a background for the some complex topic. Thank you.